Assalamualaikum my students, Answer here, welcoming you again to our online classes. Now beta, I hope you must have given your full concern to your previous lectures, to your previous talks. Now it is the time to go for the another unit, that is differential equation is. Today we are going to discuss what this differential equation actually means. We know that the equation, if we have equality sign between two expressions, at that time we call that expression, that equality, we call that equation. And now when we have an equation that is of the form this 2x plus 3x, 2x is equal to 0, we call this equation as polynomial equation, and after that we say that this polynomial equation has degree 2. So when we have an equation that is in terms of that is polynomial first, that have this power as, that have this exponent as integer, positive integer, then we call that expression as polynomial. And when this polynomial is in one variable, we say that this is a polynomial in one variable. And after that we discuss the various types of polynomials in one variable. First we discuss quadratic, and then linear, quadratic, cubic, biquadratic, and so on. Similarly, we have to do for the differential equation. First of all, we will check what the differential equation actually is. If we have an equation that involves this independent variable and dependent variable, and also the differential of independent variable with respect to independent variable. I am saying, if we have an equation that contains variables independent and dependent variable, and also contains the derivative of the independent variable with respect to independent variable, that very equation is called differential equation. For example, we know that what is independent variable and what is independent variable. Independent variable is that variable whose value is determined by the value of dependent variable. So how, if we have this y equals to f of x, for example, we know that when we will give the values of this x, it will determine the value of this y. At that time we say that this y, this x, whose values are independent, because we are giving the values of x by ourselves, and the values of y are dependent on this value of x, because whenever we are giving the values of x, that gives us corresponding value to this y. So this is called the independent variable, and this is called the x is called the independent variable, and this one is called the dependent variable. And now if we have how we can find the derivative of this dependent variable with respect to independent variable, we know that in differentiation how we can get that. That means we have this dy by dx, it is called the derivative of this differential independent variable with respect to this independent variable. For similarly, I can find the second derivative of this, that is this d square y divided by dx square. It is called the second derivative of this dependent variable with respect to independent variable. If we have now the equation that contains these two independent and dependent variable, for example, if we have this y equals to x plus, this is the equation now because it has equality sign, and it contains this dependent variable and independent variable. Now also, if this equation has now the derivative of dependent variable with respect to independent variable, that means if it has either this dy by dx, or if we have equation 5 plus 2x plus y is equal to d square y divided by dx square, or if we have an equation now that is d square y divided by dx square power 1 divided by 3 equals to 2 divided by dx plus x plus y, or if we have an equation like this d 2y divided by dx equal to dy by dx. Now you check these equations. These equations have dependent variable as well as independent variable, and has the derivative of dependent variable with respect to independent variable. Similarly, this one has also the dependent as similar for this. So all these equations, they contain this independent variable and dependent variable as well as the derivative of dependent variable with respect to independent. These kind of equations are called differential equation. Now we are going for the definition of this differential equation. You write down. You write down like this: an equation which contains independent variable, dependent variable, and the derivative of independent variable and the derivative of dependent variable with respect to independent variable is called differential equation. It's called differential equation. For example, dy divided by dx plus 5 equals to xy. d square y divided by dx square plus x plus y equals to 0. This is the definition of the differential equation, and these are the examples that can make you easy to understand it. Okay, beta, this was all about the definition of differential equation. Now we will discuss two things for this differential equation that are very important. First one is order, and the second one is degree of differential equation. You don't worry, we are going to discuss only these two things for the differential equation today, and tomorrow we will go further. But you have to concentrate fully here today, because these two are very important for the differential equations. We know that this part I'm going to discuss first the degree, because this order is very simple, but this degree is very little bit complicated to understand. So we will go for this degree first. We know that this differential equation is the equation which involves variable, independent variable and dependent variable, and the derivative of the dependent variable with respect to independent variable. Now, when we have an equation that is of this form, x square plus 2xy plus 3y square is equal to 0. When we have an equation that is of this form, clearly we don't know how to find out the degree of this, because we only know the degree of those equations which are polynomials in one variable. For example, this x square plus 2x plus 3. We know what is the degree of this equation. That is the degree of the highest power of the x. That is the degree of the power of the highest power of the variable. That is 2, and this 2 we call the degree of the equation. But here we have this x has here degree of 2, and here we have y also power 2. But we can determine it further. But here we cannot say the degree of this is 2 or the degree of this is 3 or 4, because we don't know. Now, similarly, if we have an equation that is of this form, x 1 divided by 2 plus 2x 1 divided by 3, 2x plus 3 is equal to, if we have an equation that is this type. So we know that clearly this is not actually the equation, the polynomial. It is equation, but it is not polynomial. Why? Because the polynomial is the expression, algebraic expression, or that's the equation having this variable exponent as positive integer. But here we have positive rational number, that is 1 divided by 2, and I can say that this x has radical as exponent. When the exponent is in terms of root, or when this becomes radical, so we cannot determine at that time the degree of this equation, this polynomial. Similarly for the differential equation. Now, for the differential equation, how we can find out the degree of the differential equation? Just for the polynomial is in one variable, just as what we are doing there, similar procedure we have to follow here for differential equation. In order to find the degree of the differential equation must be polynomial in terms of y. Just as we find the degree of this equation, x square plus 2x plus 3 is equal to 0. We get its degree only when it is a polynomial in terms of x, and we say that degree of this is the highest power of the x. Similarly, when our differential equation is as the polynomial in differential. For example, if it is the polynomial d square y divided by dx square whole square plus 2 dy by dx plus y is equal to 0. You check here, it is a polynomial in terms of d square y divided by dx square. It is a polynomial in terms of derivative. This polynomial, we can determine here the degree of this polynomial. But if this equation is not a polynomial, then we cannot determine its degree. So here, in order to find out the degree of the polynomial, the equation must be, in order to find the degree of the differential equation, the differential equation must be polynomial. And in the differential equation, these powers should not be radical. That means they should not be either as root or something else. So here we stop. Now it is about the degree, how we can find out the degree. I am going to tell you again here, but here we know how to find the degree now. In order to find the degree of the differential equation, the differential equation must be as polynomial in terms of derivatives and for order. If we have a differential equation now, I will take a simple example, dy divided by dx plus 5 d square y divided by dx square is equal to 2. We know that this is a differential equation because it involves the dependent variable, independent variable, and the derivative of dependent variable with respect to independent variable. What is the order of this differential equation, or how we can determine the order of differential equation? The order of differential equation means the highest order derivative present in the differential equation. I can say in simple words, sorry my students for making wait, it was actually necessity outside. Now beta, we know that the degree of the differential equation we can only exert when we have a differential equation as a polynomial in terms of the derivative. So if we have now we are going to determine what order actually the differential, what is the order of the differential equation. If we have a differential equation, for example dy by dx plus d square y divided by dx square plus is equal to 0. If this is our differential equation, or if we have like this, d square y divided by dx square plus d cube y divided by dx square d cube plus 2xy is equal to 0. If we have an equation, differential equation that are of the form this or either this, so how we can determine the order of this differential equation. The order of the differential equation is simply the highest derivative present in the equation. What is the highest derivative present in this equation? Here it is the differentiation of y with respect to x, but only one time. Here it is the two times. So the highest order derivative here is this one. So how many times? Two times we have differential. So it is order, we are saying order of the differential equation is 2. Similarly, when we are going for this equation has this as derivative of second kind. 2 times we have, and this one is 3 times. So highest order जो है यहाँ पर, that is 3. So we are saying the order of this differential equation is actually the 3. So in simple words, the order of the differential equation is actually the highest order derivative present in that equation. So now we will go for the definition of this first order and then this degree. You check here. We know that degree of this polynomial x square plus 2x is equal to 3. The degree of this equation is the highest power of the x. Similarly, the degree of the differential equation plus dy by dx plus 3y equal to 0. Just as the degree of this is the highest power of the variable x, similarly the degree of the here is the highest power or highest exponent of the highest order derivative. What is the highest order derivative? That is this. And what is this power? That is 3. So degree of this polynomial is 3. But if we have this polynomial as d square y divided by dx square, and we have this as 1 divided by 3 or 1 divided by 2 plus dy by dx plus 3y is equal to 0. Now how we can determine the degree of this equation? We cannot determine that because the power of here, this is equation, but it is not the polynomial because the power of the highest order derivative is 1 divided by 3. That is radical, and we know that the power should be always positive integer. So it is not determined. So we cannot determine the degree of this, but we can find out the order. What is the order of highest derivative present in this one? That is d2y divided by dx. So it is order is 2, but it is degree we cannot find out. So for a differential equation, sometimes degree is not there, but order is. So order is not sometimes, order is defined always, but degree is not always defined in a differential equation. So you go for definition now. Order of differential equation. The order of the differential equation. The order of the differential equation is simply the order of the differential equation is simply the highest order derivative. Is simply the highest order derivative present in differential equation. For example, d square y divided by dx square plus dy by dx whole is power 5 plus 5xy is equal to 0. Order is highest order derivative. What is that? That is d square y, that is 2. So order is equal to 2. This is our definition of order. So you go for now degree. degree of differential equation. Just as I told you, degree of differential equation is only determined when the differential equation can be expressed as a polynomial in terms of derivative. So you write down degree of differential equation is defined or determined as the highest power of the highest order derivative degree of differential equation defined as the highest power of the highest order derivative if the differential equation is polynomial in derivative. If the differential equation is a polynomial in derivative of dependent variable with respect to independent variable. Is polynomial in terms of the derivatives are dependent variable with respect to independent variable. That is, if the exponents of derivatives, are positive integers. So you write in bracket without, that is, powers are not radicals, or you also write down there for your convenience that powers are derivative are not in fraction or in denominator in fraction. So neither the derivative should be in fraction, because if it is a fraction then it will not be polynomial. If the exponent of this equation, the differential equation, is radical, is not a positive integer, then we cannot determine the degree at that time. For example, you write here. I will give you an example. You write down here, find the order and degree of the following. First one, d square y divided by dx square plus 5 dy by dx plus 4y equals to 0. B part, you write down like this: d cube y divided by dx square plus y square plus e raised to power dy by dx is equal to 0. You write the C part: d cube y dx square plus Yes, this one sine dy by dx is equal to 0, 3, and d part you write down d square y divided by dx square 4 is power 3 plus dy by dq y divided by dx square plus dy by dx is equal to 5x y. So these are the equations. You have to find out the order as well as degree. I will do the solution is here. You have to write them properly in your book. Now beta, first equation. We have to find the order and then degree. What is the order of this equation? The order means the highest order derivative. What is the highest order derivative? That is d2y divided by dx square. So its order is 2. So you write order is equal to 2. Now, what is degree? Degree is the highest exponent of the highest order derivative. What is the highest order derivative here? That is d square y divided by dx square. But we know that degree we can only determine when the equation is polynomial. When the differential is not in denominator, when this power is not radical, or this so on, that make us that this differential equation is not actually polynomial. So here, when you check this equation, it is clearly not a polynomial. So when this is not polynomial, we know we cannot determine the degree at that time, because here why it is not polynomial, because the derivative comes in denominator here. So degree is not defined. So in this equation order is 2, but degree is not defined. Similarly for this equation, you check order is 3 because the highest order derivative is d cube by y divided by dx square. Though we write here order equals to 3. But what is the degree? Degree is the highest power of the order, but we know that highest order derivative, but we know that we can determine degree only when the differential equation is polynomial. So here you check, this is dqy divided plus y. Here this e raised by dy. So power is here the derivative. So this is not a differential equation, this polynomial. So when this is not polynomial, so order degree is not defined. So here degree is again not defined, because this equation, this is not a polynomial in terms of derivative. Similar for this, again order is 3, but the degree is, what is degree? Highest power, but highest power only when the differential equation is polynomial. But here you check, the derivative comes in as angle here, so it is not again the differential equation or polynomial in terms of dy by dx. So again degree is not defined. Similarly now here, it is highest order derivative is here d cube y divided by dx square. So its order is, but when we look it properly, we see this differential equation, it has exponents as integers, positive integers, and it has also order, and in this equation we clearly getting it as polynomial, because it has neither any radical nor it has any fraction of derivative. So this is clearly the polynomial in terms of dy by dx. So what is now the degree? The degree is now the highest power of the highest order derivative. What is the highest order derivative? That is this. What is this power? Highest power, that is 1. So because it has no, so it has 1. So its degree is now 1. So this is our today's concern. So we have done enough for the this order and degree. I am hopeful that you must have grasped everything that I have given you. But now I am going to give you some home assignments, and you have to find out the order and degree of that those of the following of the home assignments. Now the first one I am going to give, write down. You write down the equation is now, you have to find out order and degree. So for order, you can determine the order easily, because you have to check whether the highest order derivative of the equation. But for degree, you have to find out first whether the differential equation is polynomial or not. So the first one is, from this you have to find out that so the first one you write down dy by dx is equal to e raised to power x. Second one, only you have to check the whether that this equation is polynomial in terms of dy by dx. If it is polynomial in terms of dy by dx, the rest you have nothing to do for the rest. So you this one. So now second one you write down dq by dx square d cube y divided by dx cube plus x square d square y divided by dx square is equal to 0. Second one. Third one you write down d cube y divided by dx square plus 2d square y divided by dx square का whole square minus dy by dx plus y equals to 0. You write down this. And the fourth one you write down dy by dx square plus dy by dx plus minus sin square y equals to 0. These are the equations, differential equations. You have to find out the degree and order. Now we have last thing that we are going to define here, because that is very easy. And you have to write the definitions by yourself, what I am going to tell you now. We know that an equation is linear if and only its power, x square, if polynomial of x is, if we have this polynomial equation, and we know that it is linear if and only if the degree of this polynomial is 1. So similarly, if the degree of the differential equation is 1, that differential equation is called linear differential equation. And if the degree is greater than 1, then the differential equation is called a non-linear equation. So you can define these two by yourself, but I'm going to here say something. If we have now linear differential equation, that is clearly that can be written as this, like this: P1 d n minus 1 plus so on plus qy equals to 0. So the differential, if the equation that is of this form, linear, we know that if the highest power is 1. If we have an equation, differential equation that is of this form, or if we can write any equation of this form, then we say that equation linear. Why? Because we know that here the highest derivative is this dny divided by x, and its power is 1, so its degree is 1. So this is linear, and it is the general linear equation in the general linear differential equation. And if we cannot express a differential equation in terms of this, then the differential equation is called non-linear. So this is enough for today. So you can write down like this: d cube. For examples, you can give like this: d cube y divided by dx square plus dy by dx plus 1 equals to 0. You can show that this is the linear because it has highest degree 1. So similarly, you can get another non-linear. You can write on this: d cube y divided by dx square का whole square plus dy by dx plus 1, or dy by dx and again dy by dx plus 1 plus x square is equal to 0. So you check here, this is the differential equation which we can write, which are of the form this one, and clearly this has degree also 1, so this is linear. But here you check, this is differential equation having order 3 but degree is 2. When the degree is 2, so that means the degree is greater than 1, so it is not linear differential equation. Similarly, this one has this dy by dx into dy by dx, that is in product. So the order is here y, but the derivative is, when we check it, it is dy by dx power 2. That means this has again a degree as 2. So this is again not linear differential equation. This is enough for today, and inshallah we are going to solve some examples tomorrow, and we will go further. We will go for the solution of differential equation and so on. This is enough for today. Have a good time.